First example, let's go over the substitution method. We're going to solve this system using the substitution method. 3x minus y equals 13. 2x plus 2y equals negative 10. Substitution means we are going to find what one of these variables equal and substitute its expression into the other equation. And in this case, that variable, I'm going to say in the first equation, will be for y. So let's go through the process from chapter 1 of trying to isolate a variable, where we get 3x to the other side by subtraction. So step 2 is substitute this expression, 3x minus 13, substitute this expression for y using the other equation. Substitute the expression for the variable in the other equation. So in this other equation, instead of this y, I'm going to put 3x minus 13. And let's put it in parentheses. So instead of that variable y, I put in the expression 3x minus 13, and now I solve for x. I'm down to one variable. Let's solve for the x coordinate of this point. So far we have an x coordinate of 2. Last step is to use this x coordinate and plug it in. Plug it into one of these points, or one of these equations, and figure out what your y coordinate is supposed to be. Using that x coordinate, I'll put my work here. You choose one of these equations. You choose and plug in 2. So if I choose that first equation, just because my eyes typically go to the first equation, I'm going to plug in 3 times that x coordinate I found of 2 minus y equals 13 and solve for the y coordinate. At this point, if negative y equals 7, then divide by negative 1 and y is supposed to be negative 7. Writing it up here. Purpose of this is to solve the system. When you solve a system, you end up with a point that satisfies both of these equations. So you got to figure out, wait a second, after doing all of this work, what in the world do I keep? I need to end up with a point, an xy point. So I'm going to put in the x coordinate that I found 2 and the y coordinate that I found, which was negative 7. That's my point. Next example. First step was to isolate a variable. You pick a variable. I'm going to pick this one. And it's because it does not have a coefficient. And what's even better is it's a positive y. So all I have to do is one step to get y by itself. So I solve for a variable. I'm going to take this expression, 2x plus 6, and use it to substitute for y in the next equation. If I used the first equation, then I'm going to use the second equation for my substitution. So we have 4x minus 2 instead of y. I want the expression 2x plus 6. When we substitute, it completely replaces a variable. When you do the substitution part, you should only have one variable left. And I notice that I only have x's left, so I can solve. So we've got a red flag here because 4x minus 4x is nothing, and we're left with negative 12 equals 5. So then we come up to, what in the world does that mean? Ask yourself, does negative 12 equal 5? Since negative 12 does not equal 5, yeah, it's a no solution. These two lines, wait a second, these two lines have no solution. When did we get no solution in a graph? If these two lines are supposed to be parallel, that means their slopes should have been the same. One of these slopes would have been this 2. If you would have subtracted that 4x and then divided by negative 2, you would have gotten the same slope. So it's a way to check. If you get a no solution, check to see if they would have had the same slope. So moving to, your book calls it linear combination, but you know it as elimination. Elimination means you're eliminating a variable by producing a similar equation. Sometimes you may have to multiply an entire equation by a certain number, so that way when you combine these equations, a variable is eliminated. I don't even know if there's steps to go with it. If you can automatically see that if you combine these two lines, if you can automatically see a variable is going to go away, and I'm not going to go into this detail, you guys learned this in Algebra 1, but notice how the y's, I've got a negative 3y, positive 3y. If I were to get the x's together, get the y's together, the y's are the variable that gets eliminated. So I'm left with a negative 1x, or a negative x, equal to 5. Right away we see that the x-coordinate of this point is going to be negative 5. Like the substitution method, now you're going to use this negative 5 in one of these equations to figure out what your y-coordinate is supposed to be. Instead of x, I'm now going to put in negative 5 and solve for y. So after we end up, okay, we solved for both things. Solving a system of equations ends up with a point of where they intersect. It's a point that satisfies both equations. I need an x-coordinate, which I found to be negative 5, and a y-coordinate, which we found to be 0. That point satisfies both of these equations. Sometimes you don't immediately have a variable that goes away if you were to add them. And this is where you have to multiply an entire equation by a certain number. So you've got to figure out, you pick a variable. If you want to eliminate the x's, you got to figure out, okay, what can I multiply here and multiply here to where if I add them, we get a 0. Maybe you, or if you pick the y's, what do you have to multiply by? If I want to eliminate the y's, all I would have to do is multiply this by a 3, and then I'd have negative 6 with a positive 6, and the y's would be eliminated. Divide by negative 7. The x-coordinate of our point will be negative 7. I'm going to use the first equation and substitute the negative 7. Add 14 to both sides. So then divide by negative 6. So we get a fraction reduced, negative 5.5, negative 11 halves. We get to a point where, okay, what is my answer? Anytime you solve a system, it ends up being a point. You've got to write that point. X, Y, this is the point that satisfies both equations. 5 problems. Page 152, numbers 11 through 13. Numbers 26 through 28. You actually have 6 problems tonight. I want you to practice doing substitution for the first 3, elimination for the second 3, because on your test next week, I am going to stress, I want to see the substitution method. I want to see the elimination method or the linear combination method.